Right. Okay, so to do gradient descent with logistic regression, so z is gonna equal to our prediction, so w1 plus or w1 transpose x plus b, and I'm gonna put this in a rectangle, and then we're gonna take the sigmoid and we're gonna call that a. So a is gonna equal to the sigmoid of z. Um, and then we're going to take the loss of this function, and actually it's better if I say y prid is going to equal to the sigmoid of z. Actually, sorry, y prid is going to equal to a is equal to the sigmoid of z, and then we're going to take the loss of this function, so the loss of a, which is the sigmoid of our prediction. Oh, right, okay. So a, which is the sigmoid of our prediction, and y, and I showed the loss formula in the last video, so if you forgot that. So this is pretty much what's gonna happen. Now, to do gradient descent, we need to get the derivative, obviously, of. We need to get the derivative of. What's it called? We need to get the derivative of w, obviously, and our derivative of b. So derivative of w is just gonna be the derivative of yeah, wait, the fuck? Okay, yeah. So the derivative of w is gonna be our x values, right? Our input values, and it's gonna be that times the derivative of z, right? So derivative of z. No, and actually, let me do that in a different color. It's gonna be times derivative of z. Now derivative of z is gonna equal to, I'm pretty sure it's derivative of L with respect to A times the derivative of A with respect to Z. I'm not gonna do the math for that. You can Google it if you want, but it's pretty much just gonna be A minus Y. So literally just the sigmoid of our prediction minus the observed value, or the actual value. And the derivative of b is actually just derivative of z. It's every single derivative of z, obviously. So it's going to be derivative of zi. So pretty much derivative of z is going to be like this. It's going to be a matrix of, this is how we're going to do it. So derivative of z, and actually, let's just say 1, 2, you know. So every single derivative of z. And I can just say derivative of z1, derivative of z2. Alright, so every time it's just going to be prediction minus observed twice, and then 3, 4, 5, 6 times, whatever. And the derivative of w is going to be, yeah, I already showed the derivative of w. And it's just every single x value times the derivative of z. And if you have multiple if you have multiple variables like this w, there's only w1 here, it would just be w1 equals this, and then w2 2 equals this, just over and over again, but we only have 1 in this case. Okay, so now that we have the derivatives of that, I'm gonna open a new Paint app or instance, whatever. So if you remember when I said derivative of w is gonna be all of our x values. I don't know why I made that so big. It's gonna be all of our x values times all of our derivatives of z, and we can actually vectorize this. So this is just gonna be x1 times derivative of z1 until xm times the derivative of zm. So this is what's gonna look like vectorized. We're taking the dot product of this. So the dot product, and likewise with the derivative of b, instead of just multiplying it, it's gonna be derivative of z1 to derivative of zm. So if you know NumPy, one way we can do is np dot sum of derivative of b, and this up here, this is gonna be np dot. So we're just gonna do np dot x, all of our x values and all of our derivative of z's. So what that's gonna look like here is it's gonna be like this one right here. If you don't know vector multiplication, we just take the dot product, and it's gonna multiply first one, second one, and it's just gonna do that until it's finished, and np.sum for the derivative of z to get us the derivative of b. Now, how we're gonna, what's it called? How we're gonna, actually, you know what? I'll show this in the next video.